Binomial distribution, we're working on a word problem. Now we haven't written out the whole word problem, but we've kind of summarized the information. Number one, they've told us that 5% don't show up for. So in other words, we're talking about an airline, and this airline's figured out that 5% of its customers don't show up for flights. Okay, every overbooking is $200. The flight also, when they overbook people, they pay them out $200. Okay, there is a 240-seat flight, and they overbook it purposely by 5%. What's the expected payout? So what's the EX? The expected payout on a flight like this. Okay. So first of all, if you overbook by 5%, how many seats are you actually booking? So we need to figure that out. In other words, an overbooking of 5% really means 100% plus 5%, which is going to give us 105%, right? So that's how many of the seats are booked. 105% of seats are booked. So what that means is we take 240, multiply by that as a decimal is 1.05 to find out exactly how many seats are booked. Times 240. And it turns out that 252 seats are booked on a flight like this. Now, we know the expected payout is $200 each. So what we need to figure out now, okay, if 5% of people don't show up, we have our binomial distribution. There are many probabilities we have to find out. Because there's 152 seats booked, but only 240, that's an extra 12 seats booked. So what we're trying to find out now is the probability. So first of all, the probability that all 252 people would show up. Okay, so the probability that we are overbooked by 12 people. Okay, so we got to figure out what the probability of being overbooked by 12 people is. Now, if 5% of people don't show up, that would be the success.
That would be success.
Failure rate. 5% of people don't show up.
I was thinking, I don't know that.
How are we going to set this up? Let's think about it for a second. So, sorry, we got a little confused there. This 252 is going to be our number of attempts. Okay? And what we're trying to find out in the very first option is the probability that all 252 people show up. Okay? So if all 252 people show up, what's the probability of this event happening? Well, we have choose 252, choose 252. Right? Probability of 252 people actually showing up. The probability of people showing up is what? 95%, right? So our success rate is 0.95 to the power of 252 successes. And our failure rate, people not showing up, is 0.05 to the power of 0. That's our first formula, okay? And maybe on the side you can calculate that as we kind of write out the next one so we get an idea of the pattern. The next thing we're going to look for is the probability of 251 people showing up. So of 252, choose 251, probability again, 251, but this time there's one failure we expect in this one. We're going to continue this pattern down to what number?
242, 240.
Well, if we go to 240, that's the probability of 240 people showing up. Will we pay any money out for 240 people showing up to a flight like this? No, because everyone will get a seat. So what we're doing is we're just calculating the probability of every overbooking. So the last possible overbooking would be a probability of 241. So if 241 of the 252 people booked. So if there's 252 people booked, what's the probability of 241 of them showing up? Probability again, 241, 0.05. And in this one, this is a failure rate of 11, right? So you get those probability. We need to take all of these values after that. When we get all of those, what we're going to be doing is we have to do a little bit of multiplication. Okay. First of all, our expected values in this case, right? Because we'd run that simulation and get our probabilities. Let's just say the very first one, just for argument's sake, is who knows, a 5% chance. Okay, and we can figure that out after. If we have a 5% chance, that's of 12 people overbooking. times that 0.05% chance. And then how much do they have to pay each time?
200.
Times that $200. Okay? That would be of the very first scenario we dealt with. Okay? Then we'd be adding into the second scenario. Do you want to actually just quickly, I'll do the second one, you do the first one, we'll calculate these actual probabilities.
All right.
Okay, so 252, choose 251. Oh, my calculator doesn't go. Can't do those permutations.
Here, you do this one, I'll do this one because
Yours can do that? Okay, okay, I'll do the first one, you do the second one. Okay, so the first one's actually nowhere close to 5%. It is 0. I'm going to write it down. 1, 2, 3, 4, 5 zeros. So let's find out the exact expected value. 12 people showing up, the probability of that event is 4, 5, 2, 4. Did you find out the second probability? Probably really small.
Yeah.
Okay, so 5 decimal places over, so there'll be 4 spots in front of that. So you're looking at 1, 2, 3, 4, 3, 2, 2, 8, 4. Okay, so that's the probability of the second event. So the first one, extremely small, 0.000002434, times those all 12 people times the $200. So this is how we do our expected value. The second scenario, 11 people times our probability, which is 4 zeros, 32284, times that $200. So this pattern is going to continue. Then we get 10 people with our probability times $200. Then we get 9 people times our probability times $200. And we're going to add all of these values up. So in the very first instance, the amount of money they'd actually have to pay out, I'm going to calculate it just for the very first scenario, okay? The expected payout just for scenario 1. For scenario 1, the expected payout is 12 times 0.123452434 times 200. So they are expected to pay out 0.00584, not even a penny, less than a little more than half a cent. That's what they expect to pay out for 12 people. That's the idea of the probability of that event happening. And we add all of these payouts together. So we'd have to run this whole simulation to actually figure out what it's going to be in this case. But does this idea make sense to you? Yeah. It will take quite a bit because we have to go through 11 different scenarios calculating them all. All right, so when we calculated them all, maybe I'll do that in a second and we'll come back to that.